right, so let's look at the question here. The first part is to actually express this quadratic expression into the completed square form. Okay, so basically you just need to show a bit of the working from here. So it depends your preference on how do you actually express it into the completed square form. Okay, each of you have like a different preference to that, so you just use your own way to actually do that lah. Okay, so here I'm just trying to do that first. Okay, so very quickly we are getting this result. Okay, so this is the result for the first part. So certainly it is actually helpful for us to actually move on. Like for the part B here, so now they have a function f. So the function f you can see is exactly the same as what we have earlier. And we also notice that, okay, the domain that is actually given here is actually like x is less than or equals to 4. So we're supposed to find an expression for the f inverse and state the domain of the f inverse. The inverse that involves the quadratic is always like a very popular one. So we really need to make sure that we know how to do that. So for myself, okay, I actually prefer to use the method where I will let the y to be the quadratic functions there. So as we actually do the quadratic functions in this case, right, we are not using the original one because our aim later, if we actually do this, is that we want to actually have like the x in terms of y. Okay, if we actually do that. So because I understand you actually do something like x is equals to f of y like that, but this is not something that I recommend, okay, because we might actually miss out something later. So usually I will just use this method here, okay. So it is not by equating like the y to this original form. It would work better if you actually look at like the completed square form. Okay, without the completed square form, we are not able to make the x as a subject here. So we must always do this. Okay, it's easier for us to actually do that. So slowly, we will actually have x plus 3 squared is this is y plus 7 over 2. So the next step, of course, is we know that we are going to have the square move over there. So remember, this is we need to move the square over, and then we have the plus minus first, okay, before we decide. So we just have to leave the plus minus there first. Okay, so in this case, we have to choose, okay, it's a positive or negative. So remember, it is not always that we just take the positive, okay, it will be either positive or negative. How do we actually do the decision here is to look at the domain. So because we want the x here to be less than or equals to 4, okay, the x here is actually less than or equals to 4. So in order for us to actually get the value which is less than or equals to 4 here, then we must always take the negative of the square root, okay? If we take the positive, we can't get the value which is like less than or equals to a negative 4 here, okay? So we can say since the x is less than or equals to negative 4, so the f inverse that we actually have here is actually just change the y to the x there. Okay, this is the inverse of a quadratic, and state the domain of the f inverse. So domain of the f inverse is something that we just need to state. We don't really have to work on that. So we need to be really clear about like, okay, if you want to find the domain of the f inverse, it is actually the range of the f. So when they actually ask for the range of the f, right, something that we need to be careful already, okay? Because, okay, we just noticed that this is actually a quadratic, okay? And if you look at the completed square form here, we already know the quadratic here is actually having the minimum point of a -3 and -7. So if you actually do a bit of the sketching, right, just to be sure, -3 and -7 is something like this here. This is the curve. Okay, if we do not restrict any domain. So the domain now we actually have here is less than or equals to -4. So for less than or equals to -4, it is basically this part here. This is the part where it is less than or equals to -4. So the range of it is we need to actually substitute the values, and we have to like look at what is the value for that. Okay, so we can actually try to find out first what is the value of the f of -4. to find the y value when the x is equals to -4 in this case. Okay, so we can actually do like 2 -4 plus 3 minus 1 squared minus 7. So this gives us a this is -5. And sorry, I draw the x's wrongly. The x's should look like this. Okay, so this is it. And we know that this value here is actually a -5 already. So the range of the f here, okay, the range of the f here is actually when we have got the fx, it should be greater or equals to -5. So that gives us a domain of the f inverse is x is greater or equals to -5. Okay, so you know the difference here, yeah. Domain is talking about the values of the x. So when we actually give the ranges or whatsoever, I mean when we give the set of the values of the x here, it would be x. Range talks about the function, so it would be like fx, gx greater, less than, or whatsoever. Okay, make sure your notation there is actually correct. Okay, don't simply mix up the range and the domain there. Okay, so they don't care what is the method that you use to obtain the domain, as long as you can state it, you can get the marks from there already. Okay. So the next part of the question here, okay, it is that we have got the function g, okay, is 2x minus 3 for x is less than or equals to k. The first case here is they gave us the value of the k. Okay, solve the equation which is g of x is 193. How do we do that? So fx is when we have got like 2x plus 3, if I'm not mistaken, square minus 7. Let me check. Yeah, okay. So f of the gx is just we put the gx into the fx, right? So we don't need to actually use the expanded form because it's quite nice already. This x here, we replace it with the 2x minus 3. Okay, and we just have to tidy up from there. So it's actually quite nice. This is the 3 actually cancel off. We get a 4x squared inside the bracket, so we get 8x squared after all. So it's 8x squared minus 7 for this fgx here. So we are going to equate the fgx is equals to 193. So we actually have to solve for this. 8x squared minus 7 is 193. So it means 8x squared is 200. X squared is 25. Okay. X is plus minus 5. Of course, when we actually solve the equation, we are getting the value of the x here. So a lot of times, okay, in the functions here, we need to be super careful about these domains thingy, because it is already mentioned that okay, the x here must be less than or equals to k, and the k here is -1. So here the x is less than or equals to -1. So we can't take the value which is like a +5 here. So we can only have the value which the x is equals to a -5 in this case. Okay, function looks easy, but a lot of the trap, okay, that we might actually fall into. So just be extra careful when we solve the questions here. Okay, so this is another example when we solve the equation. Okay, so the last part here, state the largest value of k possible for the composition fg to be defined. So composing function fg is we are going to put the gx into the fx. Okay, so we are going to put the gx into the x of the fx here. So we need to have, in this case, the range of the g must actually fit in the domain of the f. Okay, so it's like, okay, what happened in our range of the g here? So for range of the g is rather simple or straightforward because it's a straight line. And then the range here is like x is less than or equals to k in this case. So the range of it for the g here will be something related to the 2k minus 3. We just have to sub the k in, then we get the 2k minus 3 already. So we need to have the 2k minus 3 is within the domain of, okay, let me just write that. Range of the g is, we have got the gx, okay, must be less than or equals to the 2k minus 3. So this range has to fit into the domain of the f. So the domain of the f given earlier is less than or equals to -4. Okay, So it means that the 2k minus 3 here has to fit in the less than or equals to -4. So 2k minus 3 must be less than or equals to -4. Okay, so we can just solve for the k here. So the k here must be greater or equals to, less than or equals to, sorry, less than or equals to -half. Okay, so this is like they want us to state the largest value of the k here. So the largest k that we have here is -half. Okay, this is the idea about it. Okay, let's look at the next question then. Okay, so you can see it's something like they like to ask about the quadratic again. Express fx in the form of like an x minus a squared plus a b. X squared minus 4x plus a 3 can be written as like x minus 2 squared minus 2 squared plus a 3. So that is like we get x minus 2 squared minus 1. Use any way or any method for you to actually like do the completing the square. We will look at the part B here. It is given that the f is a one-to-one function. State the smallest possible value of the c. So when we actually talk about like a quadratic is actually symmetrical about the minimum or the maximum point here, right? So we want to actually have like the curve here is one-to-one. So when we actually want to have the quadratic function which is one-to-one, we usually cut that into half. So we are actually considering like the x is greater than c here. The situation like this is that, okay, if this is our fx is having the minimum point of like 2, -1. Something like this lah. So we actually want to have this function to be one-to-one. So it must actually cut into half there. So we are taking the right half, not the left part, the right hand side part, because the range here is x is greater or equals to c. So our c must be actually having this value of the x here, which is the minimum point there. Okay, so the smaller c is a 2. Okay, we must take the x coordinate for the minimum point there. Okay. So if you actually look at the next part, so now given that the c is equals to 5, find an expression for f inverse and state the domain of the f inverse. So this is some similar question again. So the c is a 5. Okay, so it's if the c is actually like a 5 here, right? So it might be the function is here already. So the function is actually from here onward. So this is our function, okay, when c is equal to 5. So, okay, here, when we want to find the f inverse, okay, it's the same thing. We let the y to be the function just now. Correct or not? Let me check. Okay, yes. So just rearrange it. So we get like x minus 2 squared is y plus 1. X minus 2, here we need to take the plus and minus of the square root. Yeah. We only decide later. So here we already know that the fx, right, the domain is that x is greater or equals greater than, not equals to, greater than a 5 here. Okay, so in order for us to get the value which is like greater than 5 from here, we need to make sure that the square root is taking the plus. So since the x is greater than 5, then our f inverse that we need to take here is when we have 2 plus, and then we've got like a x plus 1 for this function here. So you can see the similar thing happen here. So they ask us to state the domain of the f inverse. So domain of the f inverse is a range of f. So to get the range of the f, okay, we just need to look at the graph here. So when the x is equal to 5, we need to find out what is the value there. So we can actually try to find f of 5. So we sub in the x equals to 5, then we will get that fx value or the y value here. That is 8. So in this case, the range of the f here is actually like a fx is greater than 8 because there is no equal sign there. So this gives us that the domain of the F inverse is where we have got the x is greater than the 8. Okay. So the next one is to find an expression for the fgx and state the range of the gf. Okay, let's see. Gfx here is we are going to look at the fx, we are going to substitute that into the g. Okay, so gfx is actually equals to 1 over this whole thing x here, we need to sub in the this expression, okay, x minus 2 squared minus a 1. Okay, this is our what is that, fx, and we have to plus 1. Okay, because the gx looks like this, we need to sub the fx into here. So at last, it actually gives us some very nice expression at the end. So it's a 1 over x minus 2 squared. Okay, so this is another thing that we students might like usually be wrong, because okay, we just need to remember, yeah, function gf. What is the domain of the function gf? So the domain of the function gf is the same as the domain of the f. Okay, why is it the reason that the domain of the gf is same as the function of the f? How do we actually calculate the value of the gf? We sub the x, right? So which x does this like belongs to? Which function does it belongs to? So in fact, this x is actually belongs to the fx there. Okay, so that is why it is actually considering, we are actually considering the domain of the f here. Okay, and just the domain of the f here is x is greater than 5. Okay, so when the x is greater than 5, it is so natural for us to actually consider that, okay, we just find the value of the 5 from there, right? It's so, I mean, so automatic. Okay, we know it's actually like working like that. It's a 1 over 9. Okay, so when we actually look at like the 1 over 9 there, right? And then, or we just look at the domain here is actually greater than. So we will expect that the range is also greater than. So we will actually write like, okay. So we actually say like, okay, the range of the GF here, we just follow the sign in the domain there. So it's like, okay, the GF X here is just greater than 1 over 9. Okay, in fact, this is super wrong, okay? This is definitely wrong there. So, I mean, for this kind of the function, it's a reciprocal function, first thing. Reciprocal function is where when the x increases, the overall will actually be decreasing. Okay, so when the x is 5, of course, we are getting the value of the 1 over 9. But as the x here is actually getting bigger and bigger, overall, the value is actually getting smaller and smaller. Okay, here, if you write this, okay, another wrong thing is, okay, when we say that it is actually getting lesser and lesser, right? So we might say that, okay, the gfx for the range here is less than 1 over 9. Another wrong thing. Okay, why is it like that? When, okay, you see, when the x is actually getting bigger and bigger, so what happened in the denominator there? It is actually like an infinity. Okay, so when we have got the 1 over infinity, it is just giving us a 0 only, and it wouldn't give us a negative value. If you actually say something like this, right, it means that it could have negative value, but in fact it is not. It will only go to the 0 at the end. Okay, so the correct version of that, the correct answer here should be, okay, the correct answer here should be the range of the GF here is where the GF is in between 0 and 1 over 9. Okay, I mean, you also learn about the rational graphs, right? If you actually look at this one, you also know how to actually sketch it, right? For the rational graph. For this rational graph here, it is actually something like this here, man. This is where x is equals to 5. Okay, so you see that the range here is in between 0 and the 1 over 9. Okay, so it is not easy already. The questions nowadays, if you try the earlier questions, yes, they might be easy, but it's getting more and more complicated and difficult for the functions. Okay, so don't take it easy or underestimate that. Okay. Right, let's look at the next question. Do we have other questions from them? Okay, no more. Okay, next one. Find an, okay, given that we have got the fx, find an expression for the f inverse. Okay, a bit of work to do here. So usually what I do will be let the y to be the function. Okay, and then I will just like rearrange it. So here is to make the x as a subject lah. So x is 3, x is y over 3y minus 2. So therefore, the f inverse that we have here is x over 3x minus 2. This is the method that I use for the inverse most of the time. Okay. So if you actually look at the next part of the question, this part should be quite okay. So show that the 2 over 3 plus a 2 over 3, 3x minus 1 can be expressed as like this, 2x and then 3x minus 1. Okay, 2 marks question. Basically, that is to actually like combine the terms only. So it's basically the first term we actually multiply with the 3x minus 1. And then we have to plus with the 2 here. So if you actually expand the up there, we actually get like 6x minus 2 plus a 2 over 3, 3x minus 1. So we get 6x over 3, 3x minus 1. So we get 2x, 3x minus 1. So this is some algebraic work, okay, for us to actually do that. So you might wonder, oh, why do they actually ask us to do this? There's actually a reason. It's actually help us in the part C. So in the part C, they actually ask us to state the range of the f here. So what happened? So usually, how do we actually find the range of the f here? That is like, okay, we sub in the x and c log. What is the starting or the starting point of the range there log? So here the x is greater than 1 over 3. So what actually happened here is that, okay, if let's look at our let's look at our fx here. So you see, when the x here is actually 1 over 3, it will actually be something 0 in the denominator here. Okay, so when we have got sort of like a 0 in the denominator, it could mean that it is something like our infinity. Okay, so why is it like they actually ask us to do something like this here? So it means that this fx, if we actually look at this expression, it might be difficult for us to actually look at the behavior. So it would be easier if we actually use this form to look at the behavior. So whereby when the x is equals to 1 over 3, it's actually undefined. So undefined in our sense, it could be something which is infinity. Okay, because we just need the x to be like slightly larger than 1 over 3, right? Then it will give us the infinity already. Okay, and also like we know that the domain here is x is greater than 1 over 3, right? So what happens in this case is that if the x increases, okay, so overall it will actually increases in the denominator. So when the denominator is getting larger and larger, the whole thing is actually getting to 0. Okay, so when this is actually getting to 0, so what happens is that it will only give us the value which is like a 2 over 3. Okay, so we will actually have the range of the f here is actually something which is greater than 2 over 3. Okay, so this is what we actually have for this question here. So I mean, if you never learned the rational graph before, then of course you can actually use this kind of the method. So if you have already learned about the rational graph, this is some graph that you can actually plot very easily, right? 2 over 3 is the asymptote. And then you have got like 1 over 3 is the asymptote as well. So you actually get some curve which is like this, x is equals to 1 over 3, and then the y here is actually 2 over 3. So you just need to like look at some behavior and you know that the graph should look like this. Okay, so when you look at the range for this, okay, the domain is only given from x is equals to 1 over 3 onward, right? So you're looking at this part here. So you can just look at the range. The range is like from 2 over 3 onward. Okay, so this is the range for the graph here. Right? So not easy, even though it's like a 1 mark question like that. Okay, so they really like, I mean, those other questions that I didn't choose are the ones that you can do it very easily lah. Okay, these are the questions that I want to go through with you. So usually they are a bit like need us to pay attention to. Okay. So again, it's completing the square question. So let's just do the completing the square here first. Okay, this is what we get after we actually complete the square. So let's look at the next part. So, okay, suddenly they define a function already. So this function f is defined by this fx. So just check, they will, but usually it will be the same function like what we did before, but just in case you check properly, okay, it's the same function. And here they restrict the function to the domain, which is either x is less than or equals to k. So state the largest positive value of the constant k. So they already mentioned it's a 1-to-1. And as we know that this quadratic here, right, it's of course, it's not a 1-to-1, no? It has got a maximum point of a 214. Okay, it has got a maximum of the 214 there. So the graph actually looks something like this lah. So this is the point which is 214. And in order for it to be like 1-to-1, sorry, and the domain is like this here, so it means that we need to have the domain is like we take the left part. Okay, so I'm taking this part here. So the largest value of the k that we actually have here would be the x coordinate, okay, because this is x value, right? So it will be the x coordinate of the maximum point here. You just want to see the answer, so we no need to do the working one. We just need to understand the idea, okay? 1 mark for this, right? Okay, so now given that the k is equals to -1, okay, state the range of the f. Okay, so now they don't want to take the k is a 2 here, so they want to take the k is a -1. So where's our graph starting? The graph is actually starting from here. Okay, or here we don't know until we actually do the calculation. Okay, so to get that value, we just need to sub in the -1. So f of a -1 is, okay, let me just look at my function just now, -3 minus 1 minus 2 squared plus what's the value already? 14. This is giving us what is the value here? -3 squared 9 minus 27. This is a -13. Okay, so the f of -1 is something like this here, lor. Okay, this is a part of the curve that we're actually looking at. Okay, so the range for the graph here, okay, so the range of the graph f here is the fx. It should be, okay, let's see, it has got a greater equals to or not. Okay, so this is a less than or equals to -13. So based on what we actually have in this part of the curve here. Okay, so if we actually can sketch out the graph, that would be like the most helpful thing that we could do. Okay, so with that, you can actually identify the range very easily here. Okay, so okay, it's to, okay, let's see. Okay, different questions here. So find an expression for the f inverse. Again, okay, it's about the quadratic. So to find the f inverse, okay, we will have to let, okay, the y to be that -3 x minus 2 squared plus 14. I keep forgetting the functions here. Okay, minus 3x. Okay, this is it. You basically just need to like rearrange it lah. So you actually get like x minus 2 squared is 14 minus y over 3. So x minus 2 is a plus minus square root of the 14 minus y over 3. And then the x here is a 2 plus minus square root of the 14 minus y over 3. So let's look at what is the domain of the f. Domain of the f given earlier is that we have got the what is that -1, okay? X is less than or equals to -1. So in order for us to actually have the value which is like less than or equals to -1, when we actually consider this part here, we have to take the negative. Okay, we need to take the negative. So the F inverse here, we should take the negative of the root. Okay. So so this is the inverse. Okay, we have actually like tried different type questions from that for that one, yeah. So this is a little bit of the translation they add in here. So the result of translating the graph of the fx by what is that? -3, 1 is the graph of the gx. So the gx they want us to give in the form of like an expanded form. So if you actually have done this translation, is that okay? What happened? If you have got the translation in the x direction, it's a -3. So we need to change the value from the x to the x plus 3. If we actually have got the y is a 1, so it means that our fx here must be actually plus with a 1. Okay? So fx becomes like a fx plus a 1. So our gx here, okay, let's write our fx first. Our fx is -3, x minus 2 squared plus 14. So the gx is that we are going to change the x to the x plus 3. Okay, let me use other color for that so it's clearer. Okay, and then plus a 14. So and then overall we need to actually plus a 1 to that because of this. Okay, so after that we will just have to like expand. Okay, because they need us to give it in the expanded form. X plus 1 squared plus a 15. So this is a -3x squared minus 6x. And then the constant there is a 1, -3 plus a 12. So this would be the function of the gx that we would actually get for this part of the question here. Okay. All right, next one. Okay, so a bit of the different types of the question that we can see here, yeah. The function here, okay, that is we have got this y is equals to fx. That we need to sketch the graph of like the f inverse x here. So for this, it is actually looking at our understanding about how the graph works. So this, okay, f inverse should be symmetrical about the y is equals to x. Okay, if this graph is actually symmetry about the y is equals to x, right? So how does it look like? It should actually look like something like this here. Okay, so this is how the graph would look like. Okay. Hey, what am I doing? Wait, let me just see. Okay, it's not this way round, it's the other way round. It should be this way round, sorry. Yeah. Wait, Okay, this is the graph that we will actually can see from there. Okay, this one is not so nice, this one. Yeah. So it's something like this are the curve. Okay. This is the first part of the curve. Right. It's a 1 mark question. Okay. So for if you look at the part B here. Okay. So for the part B here, right? Okay, there's another trick that I can show you. How do you actually know that the graph looks like this? Because just now I also had a bit blur, right? I also draw a wrong graph here. The idea here is that I'm not sure whether this method works for you, but if you are really not sure how the inverse graph should look like, right? Or when you want to reflect it over the y is equals to x, right? You can try to illustrate it as you exchange this as x, exchange this as y, and then you actually draw it again as if like you have the graph, you just flip it like that. I'm not sure how to actually describe it, but you just flip it like that. So when you actually look at it as like the y and the x, right, it will actually give you the graph which is like, okay, you see this is what happened in the second quadrant, no? You see, earlier on, this is like the first, second, third, and the fourth quadrant, man. But as you actually like change the x and y, right? So this is your first quadrant, this is your second quadrant, this is third, this is fourth quadrant. So it means in the inverse graph, the first quadrant you need to see this. So this is what you see in the first quadrant here, like that. And then you also have got like, okay, the third quadrant, right? This one was in the second quadrant. Okay, so when it actually comes to the reflected graph here, so it should actually appear here. Yeah, something like this. Okay. So that is the first part. Okay, not easy. It's very easy to make mistake here. Okay, for the part B here, it's now given that the fx is given by this function. So find an extension for the f inverse. Okay, this one might have to do a bit of work. So we let the y to be negative x over square root of the 4 minus x squared. Okay, we might have to square both sides already. So if we square both sides, we get y squared is equals to x squared over 4 minus x squared, which we get like 4y squared minus x squared y squared is equals to x squared. So, okay, here you actually have to bring the terms together, which you are getting, this is a y squared plus 1x squared. Okay, and then, right, you are getting x squared is equals to 4y squared over a y squared plus 1. Okay, so something is happening here already. So you see, you move the square over there, right? Means that you also need to consider the plus and minus of it. Okay, so you see. So we get a y squared plus 1. So the numerator can cancel off a little bit. So we get plus minus 2y over square root of the y squared plus 1. Okay, so what you so in this case, okay, what are we actually getting for this situation here? So what is the side that we're actually going to consider here? Okay, so that is, okay, we can actually do a little bit of like the reasoning here. Okay, so here the what is that? Okay, the function here, right? Okay, earlier on we have got the x is like in between -2 and 2. So when we actually look at this one here, okay, the value here, okay, it seems like it is actually not giving us like the info, because if you actually look at like the x must be in between 2 and the -2, right? It doesn't really gives us a clear indication that whether we are actually like considering the plus or the minus here. Okay, it doesn't really gives us a clear indication for that. So from there, right? Okay, wait, let me just check my working from there. I hope I didn't make any mistake in the middle of the working, or else it will actually affect it might affect the solution there. Yeah, let me just check. Okay, let's see, is there any question followed by that? Okay, no. Um, for this, okay, let me just see. Okay, yeah. So okay, you just need to look at the situation here. This, okay, like I said, is not really helpful just now. Okay, we may actually try to look at the whether are we taking the positive and the negative, right? Okay, so for this, right, when we actually try to write the F inverse, okay, so in the F inverse here, we need to actually decide like, whether it's a plus or minus. Okay, so you can see here, right? If this one is surely positive already, lor. So this numerator is the one which determines whether it's a positive or a negative. So you can see, if this is a positive, right? Okay, so it means that if the x is a negative, okay, so in this case, I just write for you. So if the x here, if it is a positive, okay, if it is a positive, so when x is positive, the F inverse is also a positive. So let's check this, okay, against the graph there. So for this, when x is a positive value, but however the F inverse that we have, okay, the green curve here is our F inverse, right? It should actually have a negative value. So it doesn't make sense in this case here. Okay, so for that to actually make sense, we must always consider the F inverse is a negative graph here. Because we want to have like when x is a positive value, the F inverse should actually have a negative value. So this is why we're actually taking the negative here, which they sort of like already give us a hint on like asking us to actually sketch this. Okay, so for this F inverse, we are going to take the negative of the expressions there. Okay. So what we actually have in the next part here, okay, they give us quite a bit of the, okay, got two parts. So function g is defined by gx equals to 2x for the in between negative a and a. That's we need to state the possible maximum possible value of a for which the fg can be formed. So in this case, the fg here is like we are substituting. Okay, we need to have the range of g to fit in the domain of the f here. Okay, so the range of the g is actually represented by this. Okay, 2x here. So we need to actually have like, okay, you see, the range of the g here is, if the x is in between negative a and a, then the range of the g here is in between negative 2a and a. So we need to fit in this one into the domain of the f. So what is the domain of the f here? The domain of the f here is already given, it's in between negative 2 and 2. Okay, so in order for this thing to fit inside here, so we actually need to have the a to be like the a. Okay, so therefore by checking against it, so we can actually have like the value of the a here is actually a 1. Okay, we are putting this negative 2a to 2a inside this thing here. So it means that the maximum, the a that we could have is a 1. So other than that, we can't fit in inside there already. Okay. What is the last part? Okay. Assume that fg can be formed. Find and simplify an expression for the gx. Okay, fgx here. So it's to put in the fx, the gx into the fx here. So our fx is this expression. So negative. So we put in the x, which is a 2x for our g. Yeah, gx is a 2x. Yeah. Divide by, this is a 4 minus x squared. So the x here is a 2x. We are going to square that. Okay, so it's very easy lah. So negative 2x over, this is like a square root of a 4 minus 4 x squared, which you can actually factorize a 4 out lah. So including the square root there. So this is the expression that we get, okay, as easy as that. Okay. Oh, 2 marks question for this one. Okay. yeah, so that is the questions that came out recently, and to be honest, they are actually not that easy already compared to the earlier years. Okay, so that's why I purposely want to go through this with you. Okay, that's it for this